Goal is to find the surface area of the hemisphere defined by the function f of xy equals the square root of 25 minus x squared minus y squared. So let's take a look at a visual. So here is that hemisphere, and we need to determine our region of integration. So looking at it from the top, we see that is a circle of radius 5, but that shouldn't surprise us. To get our region of integration, that happens in the xy plane when z equals 0. So we are working at solving square root 25 minus x squared minus y squared for our region. So squaring both sides, we get 0 equals 25 minus x squared minus y squared, or x squared plus y squared equals 25. So our region of integration then is going to be that circle, the interior of that circle. So x squared plus y squared less equal 25. And let's graph that. And our goal is to find surface area. So let's remind ourselves of the formula developed earlier. The surface area will be the double integral over the region of interest of the square root of the partial derivative of f with respect to x squared plus the partial derivative of f with respect to y squared plus 1 dA. So let's go ahead and find those partial derivatives. We have f of xy is the square root of 25 minus x squared minus y squared. And rewriting in exponential form, we can use the 1/2 power instead. So we want to find the partial derivative of f with respect to x. That will be 1/2 25 minus x squared minus y squared to the 1/2 minus 1, or negative 1/2 power, times the derivative of the inside with respect to x, which is negative 2x. And simplifying the algebra, we get negative x over the square root of 25 minus x squared minus y squared. Let's find f sub y next. So similarly, 1/2 25 minus x squared minus y squared to the negative 1/2 times the derivative of the inside with respect to y, which would be negative 2y. And we get negative y over root 25 minus x squared plus y squared. Now we know with our formula, what do I need? I need the square root of f sub x squared plus f sub y squared plus 1. So let's do that analysis. And we get this. So let's build ourselves a common denominator. And we see we have x squared plus y squared, and then 1 is 25 minus x squared minus y squared over 25 minus x squared minus y squared. And let's simplify the algebra again. And we get 25 over 25 minus x squared minus y squared. So let's go ahead and look at our formula for surface area. The surface area equals that double integral over r of the square root of f sub x squared plus f sub y squared plus 1 dA, and there is our region R. So let's make our substitution from the previous work. So double integral over r of the square root of 25 over 25 minus x squared minus y squared dA. Now, looking at this, we recognize that polar coordinates will be a helpful strategy for us. And what do we need to know to be able to use those polar coordinates? Well, x squared plus y squared is r squared. So 25 minus x squared minus y squared would be 25 minus x squared plus y squared, which would be 25 minus r squared. So we get that much. And we also remember that dA in polar coordinates is r dr d theta. So let's look at our double integral here. What is little r ranging from? We have a circle of radius 5. So little r ranges from 0 to 5. And what does theta range from? Well, it goes all the way around the circle. So theta ranges from 0 to 2 pi. Making our substitutions in polar coordinates, we get 5 over the square root of 25 minus r squared. And then what is dA r dr d theta? And that's the integral we're going to need to work to determine the surface area of that hemisphere. So here's the integral we need to work on, and u substitution will be the direction that I want to go. So let's see, we're going to let u equal 25 minus r squared. So du dr is negative 2r. du divided by negative 2r equals dr. That'll enable me to simplify that. And then we're also going to need to change our endpoints. So if r is 0, what is u? R is 0, u is 25, minus 0 squared, u is 25, will be that endpoint. And then if r is 5, what are we going to get? U is 25 minus 5 squared, u is 0. So making those substitutions in this integral, we're going to get the following. So the surface area is the integral from 0 to 2 pi. Now, if r is 0, u is 25. We'll make that change. And if r is 5, u is 0. We'll make that change. Then we get 5 over the square root of 25 minus r squared will be the square root of r. Excuse me, the square root of u. And then I have r dr. So fine, we're going to leave r alone. But dr is du divided by negative r, 2r. And then we're going to end this thing with a d theta. So this is where we stand. And let's first do the inner integral. His integral is u goes from 25 to 0 of what? 5 over negative 2, 5 over root u, we'll just write it out as it is here. R du over negative 2r. So the r's go away, they divide out, which is necessary for a u substitution. We can only work with one variable. The 5 over negative 2 can't come out in front. So we get negative 5 halves. Then we have the integral as u goes from 25 to 0 of 1 over root u du. So that the inner integral becomes negative 5 halves. Well, actually, let's go ahead and make it positive 5 halves and switch the order of integration. I'd like to go from smaller number to a larger number. So u goes from 0 to 25 of, and then we'll think of 1 over root u as u to the negative 1/2 du. Continuing, inner integral is 5 halves. Now the antiderivative of u to the negative 1/2 would be u to the 1/2 over 1/2. Evaluated as u goes from 0 to 25. Well, 5 halves divided by 1/2 is just 5. And then we have square root of u evaluated as u goes from 0 to 25, which is 5 root 25 minus 5 times root 0, which is 5 times 5 minus 0, which equals what? Which equals 25. So my inner integral turns out to be 25. Now, the inner integral is here. So let's replace all of that with 25 and see where we get. So now I'm able to say that the surface area equals the integral from 0 to 2 pi that of course is theta equals 0 to 2 pi, of the inner integral 25 d theta, which will give me 25 theta as theta ranges from 0 to 2 pi, which is 25 times 2 pi minus 25 times 0. Twenty-five times 2 pi is, of course, 50 pi. So let's recall the surface area of a sphere is 4 pi r squared. Our problem here is a hemisphere. So if we cut that in half, the formula for a surface area of a hemisphere would be 2 pi r squared. If you remember, our circle that was the base of our hemisphere went out to 5, 0, so our radius was 5. So the surface area of our hemisphere here would be 2 pi times 5 squared, 25 times 2, 50 pi, agrees with what we obtained from calculus.